In priority setting and health economics, we are making decisions about population. And one of the good metrics or one of the good ways to study about populations is to use demography and life tables. And that's why we are going to discuss them in this main lecture. The main lecture is going to be presented by me, Castory Munishi, who is a PhD research fellow at BCEPS. So let's start with the objectives for this mini lecture. So the first objective, I want, by the end of this session, I want you to gain familiarity with the basic concepts in demography, gain familiarity with life tables and how we use them as a tool for health economic evaluations. And importantly, we want to see also how can we use life tables to calculate changes in life expectancy arising from interventions that reduce mortality. And this is like a key focus in my research. So what is demography? So demography is a study of population structure and change over time. So in demography, we are concerned about the population structure, age, number of people, and their sex, but also how does this population change over time? And time can be in 1 year, 2 years, 10 years, based on your interests. And in demography, we measure accurately all aspects of change in size and composition of the population. And also in demography, apart from learning about the current population, like how many people do we have in 2025 in a given country or in the world or in a given continent, we are also interested to know like how many people will we have in the future, 10 years from now, 5 years from now. And there are ways to study about this and make predictions. And one of the key concepts in demography is the basic demographic equation. And this basic demographic equation summarizes the way that we can calculate population changes. And population changes are mainly driven by a limited, countable number of events. And we are going to see these events. So let's consider a country at some time, and it contains a population P1 persons. And then let's look at it 1 year later. It will contain population PT plus 1, so 1 year from now. And then the demographic equation for that country will be PT plus 1 equals to the current population, which is PT, and then BT, which is the number of births, minus DT, number of deaths, minus plus IT, which is the number of immigrants, and then minus ET, the number of immigrants. So yeah, so you will see the definition of those terms used in the equation: number of births, number of deaths, number of immigrants, and then number of immigrants. Yeah. And then from there now we can look at the demographic equation in much details. So when you take BT minus DT is known as natural increase. And then when you take IT minus ET is known as net migration. And so population can only change because of 3 types of events, and that is births, deaths, and migration. And in health economics, particularly in this class where we're discussing about life tables, we're going to be more focused on deaths. But you can also learn on other fields how births and migration impact population change. And that could also be relevant in economics and planning. So fertility is the process which the population bears children, and that is, it changes the number of births. And then mortality is the process by which members of the population are reduced by death. And then the last process is immigration, migration is where people move in and out of the given area where you are concerned about the population for that area. And so therefore we have 3 demographic processes, and that are fertility, migration, and mortality. Mortality is another word for death. So demographic processes and transition between states. So the processes that we've seen, they are all interlinked. So you may have an individual who is alive, and then they may move out of the population by immigration, and then they may move back, or we may get people from another population and they come into your original population by immigration. And then you may also have people who die from your population and then they go to the death status. But this population is also contributed, the increase in population is contributed by unborn. So the arrows that are pointing towards your current population, meaning that they increase the number of people, and the arrows that point away from your current population, they decrease the number of people in your population. Yeah, so we have, as I mentioned earlier in this mini lecture, we're going to focus on mortality because it's very relevant when we want to use life tables to calculate changes in life expectancy. So there is a very simple formula. It's just a basic division. When you're calculating what we call crude mortality rate is the speed at which people die. So you take the total number of deaths in a given year, and then you take the total mid-year population. And normally we take the population of that particular location as of 30th of June for that given year. And this can also be represented by using this mathematical notation, where MT stands for mortality, and then this stands for the total population in a given year divided by the mid-year population for that country. Sorry, this stands for the number of deaths. And deaths is a relatively rare event in most population. Therefore, we normally, when you take, you divide the two numbers, you'll get a very small fraction. So to make these numbers a bit readable or easy to communicate, we normally multiply them by a factor, let's say by 1,000 or by 100,000. So here I've used an example where you multiply by 100,000 so that you can get a rate that is easy to communicate. And yeah. And then normally, when you get crude population rate, you just get crude mortality rate, you just get a single number. But we are interested on age and sex specific mortality rate because individuals of different age may have different mortality rate. For example, in most developing countries, the first year, most people, there is a huge number of deaths in the first 5 years of life. So if you calculate the crude mortality rate, you won't be able to see that. But also there are significant differences in the number of deaths between males and females. That's why we need to calculate age and sex specific mortality rate. So this is very straightforward concept where, as I mentioned, like in the crude mortality rate, we don't capture the variation. So we now focus on calculating the age and sex specific mortality rate. So the formula is very straightforward. You calculate age specific death rate at age X years by taking the number of deaths of people aged X years divided by mid-year population aged X years. And the X there could be, you can either have like 1 year age groups or multiple age groups, like 5-year age groups or 10-year age groups. But normally it's 1 year age groups and 5-year age groups. And the age X years, it means age X since the last birthday. So we consider the last birthday, individuals who have just celebrated their last birthday and they have turned into that age that we are interested on. And this can be represented by that mathematical notation. And then it's just a similar formula, but now we have like a specific age.